Hello everyone. Today I'm going to one of the Neetcode questions. This is for my preparation kind of things that I'm going to do. So this is the Neetcode website that I'm trying to solve. This is Neetcode Blind 75. This is very good for quick revision. So let's go for merge to sorted array in the linked list. So problem says that you're given the head of the two sorted linked lists, list one and list two. Now we have to merge two lists into one sorted linked list. So, okay, so here now we have to merge two lists into one sorted linked list, and we have to return the head of the new sorted linked list. So these are the two linked lists. We have to merge them one, one, two, two. So it will be one, two, three, four, and we have to also make them sorted. And then we have to the list should be okay. The new list should be made up of both the lists. Okay, so we have to return the sorted list. This is the question. So since we have the two heads given of the head of list one and head of list two, what my intuition is, I will create maybe a new list, and then I will start appending uh, the sorter one. The sorter shorter means the smaller uh, list list value, right? So this is what I'm trying to do. So for each list, I will create a new list, and then in the new list, I will start appending. So the new list should be made from the node. New list should be made of nodes from list one, list two, right? Okay, so let's start, and then we will also try to find if we can do it the other way. So here, let's say if uh, list or let's say node, we can say is mm, list node is let's say list node, and the vault that we'll give is 0, right? I think it goes like self dot list node. So I'll just check quickly through ChatGPT the syntax for the Python. Uh, how to declare a new linked list in Python. Yes, so this is all. So I think that's I was correct. So this is the one, or we can also just input a linked list we can create just by saying none. So let's go here, and then we can just declare is that none. All right. And now we can iterate. So, so while uh, list one dot next, I'll check this one is not none, and list two is not none. What we can do is here if list one uh, if list one and list two, if like I mean if both the lists exist, list two, what I will do is uh, I will just node dot wall. I'll just put the wall to be uh, with the minimum of list one dot wall, comma list two dot wall. So basically, I will take the minimum of the value of the list one and the list two if both of them exist. So yeah, if otherwise, so else if there is only list one, uh, is not none. If there is just rest one, uh, what I will do is I will just do node dot next is equal to rest one, and otherwise I'll just do node dot next next equal to list two. After this, I will just do node equal to node dot next, and after final iteration, I will just do is what I will do is I will just uh, okay, we can have temp. Uh, yeah, we can just do node. Okay. So node is equal to less two. Sure. Okay. So we will just return a res this will be equal to none, right? That is correct. So if you see we have the none and we are doing while both of them is there. So we'll find the uh yeah, we'll find the so we can do a simple if statement if list one dot wall is less than list two dot wall, meaning that if list one has lower value, then we will just do note dot next will be equal to just the list one. Otherwise what we'll do is we'll just move node dot next to the list two, and whenever we move them we also have to append the list one value equal to list one dot next. We also need to move the list two value. So we have to move list two equal to list two dot next, then the list one no dot next equal to list one. Okay, then we'll do list one equal to list one dot next. Here we'll do list two equal to list two dot next is null. Yeah, here I just need to return res. And node equal to res, right? Now node is increasing, but we have res fix. Then we can just return next. This node, let's take 0 here. So our output is less 1, less 2. The output should be 1, 1, 2, 3, 3, 4, 4. And I'm not able to get the final value, right? When I think the same thing is here. List 1, 0, list 2, 0, list 2 thing is not coming up. This is what I think. So let's check. So okay, those are not here. So it will go in here. Is not none. Is something like 0. So okay, is if is there, right? So let's check with that one. There is list 2. The 0 rest is getting assigned, and then it will not, because both of them are not there, right? List 1 is not here, so list dot next, no dot next will be list 2. Yeah, I think this should be here, right? Is not none. List 1 is 0, list 2 is 1, 0. Our output is 0. The expectation is 1 and 2. List 1, list 2. Okay, list 1 is not done, and list 2 is not done. List 1 and left. Okay. So this should be till all, right? If any of them is not there, do this process. Yes. Yeah. Here you got the answer. Let's just submit. Yeah, we are able to get the results. So now just quickly look at the solution. What they are doing is, so let's look the optimal one. So they have created a dummy node which are both equal. It's just empty. They're checking while both of them are there. Okay. And then okay, they're just substituting next to here. This area, okay. That makes sense. Similar to what we are doing. Let's move to the next question. Okay, linked list cycle detection. So given the beginning of the linked list had return true if there is cycling in the list, otherwise return false. We have to. So there is cycling in the list if at least one node in the list can be visited again by the following next pointer. Literally, a index determine the index of the beginning of the cycle. If it exists, the tail node list where the next pointer to be the index node. If index minus 1, then the tail node points to the null and no cycle exists. Okay, understand. So we're gonna have the small and the fast pointer. And then from there you can check the list, or you can just have a map. So what I think the first solution is create create a map and then store the value of the pointer return cycle if null exist, none exist, return cycle if pointer hit else if pointer hits, else otherwise just return false if none exist. And the second approach will be create a fast pointer, create a fast pointer and a slow pointer. So if none exist, then I would say to return this none, just return false. And if fast pointer catches a slow one, catches a slow pointer, then we can just return true, right? Here you can say cycle to be the true. Here you can also say cycle to be true, right? Sure. So let's start with this framework and let's move with the better optimize function because it will have the time complexity here will be on, but there will be space complexity of on. Uh, so here I think the time complexity will be big O of n, and the space complexity will be big O of n. However, here the time complexity will be O of n, and the space complexity space complexity will be, you can say, big O of 1, right? So let's create a pointer. So let's initialize the fast to be head, and which is also equal to slow. And now while fast fast is not none, while fast and fast dot next. So until here what we can do is okay, you can see if fast if fast and slow are equal to, oh, not here, we cannot do it. Okay, so what we'll do fast equal to fast dot next, and we'll do slow equal to slow dot next, and then we'll see if fast equal to slow as well slow, we can just return true, and if it's just get out of the loop, we'll just return false. Yeah, I guess here just look at the solution. Yeah, I think it's pretty the same. So fast was aligned to the head, and then just this, right? Yeah. Let's move to the next question. So we have to here reorder the linked list. So you are given the head of a single linked list. Okay, we have the head. The position of the linked list of length 7, for example, can initially be represented as head of single linked list. The position of linked list of length 7, for example, can initially be represented as 0, 1, 2, 3, 4, 5, 6. Okay, these are the positions. Reorder the nodes of the linked list to be the following order. Sure, we have just reordered a puzzle. Notice that in the general case for the list of length equal to n, the nodes are reordered to be in the following order. 0. Okay, this is the order in which it has been reordered. Okay, I got, so basically just paste it 1 for half, reverse it, and then okay. 0 and minus 0, the last one. This is how they're doing. So for example, it should be 2, 8, 4, 6, 2, 8, 4, 6. Okay. From here, it's like 2 pointers. Okay, now what we have to do? Uh so what we have to do basically, uh reorder the nodes of the linked list to be the following order. Okay, we have to reorder. You may not modify the values in the list, but instead you must reorder the nodes themselves. Okay, we have to reorder the nodes. So the one approach is to go till there and then reorder. Uh yeah, so let's see if what if what is the pattern that is repeated. See, if I have a start, I have end. If I have 2 pointers there, then what I can do, I can just transfer here, get the results, transform it, and I can do whatever I want to do, right? All right. Is there any other method? Just link them and just send them. Yeah, this is what I'm thinking. Sure. So what is my approach here? So I will do the approach of 2 pointers because the 2 parts are changing. We'll use 2 pointers. So my first pointer would be uh, my first pointer would be at the start. My second pointer would be at the end. At the end, uh, I will do the recursion, and then I will solve for it. So this is what I need to do. Yeah. So let's start from here. What we have to do, we have to reorder the list. Now, right. So what we can do, let's have start to be equal to head. Let's initialize last. So last equal to head, while head dot next is not none. Let's not be very fancy and just stick to it. So while head dot next, what we can do head equal to head dot next. After that, Okay, and after that we will just assign last we had. Okay, now we have the start one, and now we have the last one. Now what we have to do? So after this true part, what I have to do is I have to iterate from the front and iterate from the back, and then there's the recursive part that I have to send. So so yeah, let's start. Just check. Do I need to create a new function from starter? I think so. Okay. So let's have a new function that is return return. Yeah, this will return the like mm, reorder. So it will return the. So this is the function that will take these two heads. That is start. It will take the end, and then it will just. I think that's all. These are the two things that it will take. Let's define the function. So def reorder, it will take start, it will take end. It will return none. And then what it will return? It will return list, right? What we have to return here? I think we just have to return a list node. We don't have to return anything. So list node is something that we want to return. But that will basically start. So what we'll do, we will first write the base case. What would be the base case here? Let's consider there is just one element in which is like just if start equal to start and end are the same. Okay, we are doing okay. When these two are the same, what we are doing then? We will just returning the index, right? Okay, so when start is equal to end, right? What we are doing when both are the same, what we have to just return the same thing, right? So we can return start or end. So was in this case, let's say just return start. So this is our base case. Then we'll get the return. So the node, let's say will be reorder. Here it will go as start dot. And what about these two are the same? Okay. Or circle or start dot next is equal to end. These two cases will just return start. Otherwise, we will just reorder start dot next. Shit. How did I get the prev? I don't want to do that. I think there is one problem because we don't have a doubly linked list, so we cannot come back. There is one issue with that I realize now. Okay. I can do an iteration, but I think I want to do it recursively, but I also need like the next part. Let me think. Let's do it here only. I think now we don't need it because it is not forming some kind of recursion. Mm, Although it is some React recursion, so if I just send this to index here, I cannot traverse back, right? So that is one problem. Mm, think what should I do now? 0, 0, 2, 4, 6, 1, 3, 5, 0, 1, 2, 0. It's like yeah, I need to solve it via recursion. I don't want to solve it like this way. So one process will be, or one method that would be, take the 1, take the 2, take the 4, take the 6, and then take the 0, take the 6. If it is a double linked list, then it would be very useful. You can, although we can reverse the linked list, then we can wire. What should be done in this case? 0, 1, 2, 3, 4, 5, 6, 0, 6, 1. I don't want to create one more extra reverse link. That is problem. I'm just thinking if I can solve like in one pass. Okay, now something is coming like recursion. So once I'm here, I have the last value, and then what I can do is from here, once I'm there, uh, okay, I can just do start dot next. Can just put start dot next to be equal to, what's that, last. Okay, I can store a temp as which is equal to start dot next, and then this is my last, and from here start dot next will be last, so this is link to link, then last dot next will be equal to the temp, and now the temp is my new start. And from here, yeah, certainly I need to return here the start, and yeah, I have to return the start, or you can say I need to return the head. And here I just have to uh, reorder, reorder. Start will be my new head, right? Oh, sorry, temp will be my new head. Stamp is there. start is equal to head, start. We can also return start. There's no point in that. So yeah, if we need, we can just return start. I've just taken it to show it. I think yeah, this reorder list. Sorry, reorder list here. So that should work. Just need the base case. What's the base case here? So the base case here is if start is equal to last, meaning both are the same, or start dot next equal to last. Just have to return start. This is what it is. I think it should work. The time complexity can be very large. Okay, self dot. I'm not sure about this self function when we have to pass self other things. Time you have an infinite loop. Code is too inefficient. Okay, where is the infinite loop coming from? Well, temp is equal to 2. Then the temp, right? I don't think there should be any infinite loop of kind of thing. So we have this start. We have the checking while head dot next. Okay. Okay, and here we have. Oh, that's the issue. Because header is already increased, right? Last is equal to head now. When this is infinite loop, it should not be an infinite loop. This is what I am thinking. Loop will break here once the head dot next is null. The loop will break here if both of them are same. Here I am increasing the start. Okay, start equal to temp equal to start dot next. Dot next. Start dot next equal to last. Last dot next equal to temp. I see. Okay. So now I got the issue. Where is the loop is coming from? So yeah, I got one issue here now because this is forming a cycle. I have to break the cycle so that I can connect this to null. So here I'll just go till this part. Link is head. Now this will be prayer. Okay. And then if start equal to prayer dot next, or second we have the prayer. We don't need to put it here. This is all right. We just put here. What we can do here is if start, what is that? If start dot next equal to none is none. Start dot next is none. or start dot next is none. Just have to return start. There's no start, so let's call it head. So this is the base case. Now we are coming here. Okay, we are assigning the start to be head. We are increasing the head till the second next node, or that is the prev node. So we have the prev now. Now what we are doing is, okay. Okay, sure. So we have got the prev. What we'll do is, there is start and there is prev, right? And then what we can just define is last would be prev dot next, and everything will work fine. And so after the temp start next to next, temp is defined to start next to next, okay, and then it's start dot next is the last, then last dot next uh, is the temp. That's correct. That is correct. There's just one more line to write is prev dot next is none. That's it. Let it know. Look now. Expected error indentation was the wrong. What's the error in this? Maybe indentation error or something? While head dot next head equal to head dot next. Maybe I think I just use. But expected return is none. Okay, just do not have to return anything. Set to pass. Here 2, 8, 6. I understood. Okay. So here the temp is start dot next. Okay. And then start dot next equal to last. Last dot next is temp. Okay. Oh shit. Yeah, these are working. Let's submit it. Time limit can be one of the issue. What's the issue? But output was but expected type is none. What is this? How it is done? Is this error head on? Okay, the output is 0. We don't have any bond. This is what the output should be, right? We have just head, right? What I will do? What will here go? Okay, here I'm returning something, right? Okay, the speed is very slow. Let's look at the problem. They have solved it. Solution. Okay. Time complexity O(n), space complexity O1. For our case, the space complexity is O1. Time complexity, I'm not sure. It's going n, and this will go n time. I think it's O1 square. Because every time we are traversing the area, this is O(n). We will do n by 2 times. Okay, so this has been using the slow and fast. While fast dot next, so they are increasing everybody, and then okay, that is in the middle. That is in the end. second equal to slow dot next, prev equal to second will be equal to slow dot next, prev is equal to slow dot next equal to none. So basically they are prev equal to slow dot next, second is equal to slow dot next, prev equal to slow dot next equal to none. Okay, so we are basically are breaking that into two parts, and we have at the end, okay, while second. Now while the second is there, temp is equal to second dot next. Okay, second dot next equal to prev. This is the prev is none, right? Okay, while second, temp is equal to second dot next, second dot next equal to prev equal to second, second equal to temp. These three parts doing. Yeah, that's what I was saying there. So basically, that's what I was thinking as well. I do not want to, like, this is a good approach. I do not wanted to reverse the whole of this. What they have done is they have find the middle, they have reversed these two, so this will be 10, 8, and this will be 2, 4, 6. Then they have what, yeah. Actually, those one. Let's move on to the next problem. So, oh my god, how many problems are there from the linked list? Remove the nth node from the linked list. Remove the nth node from the end of the list. So given the head of linked list and an integer n, remove the nth node from the end of the linked list and return the head. Given the head of the linked list and an integer n. So where is the head? This is the head. This is the integer. Remove the nth node. Okay, from the end of the list. And return its head. This is the two we have to return. So there are two options. The first one is return the linked list and then get to the nth point and return again. The second approach is, I think, again, is the fast and slow. So what you can do if you have to, let's say, if the size of the string is 1 2 3 4 3 4 and you want to return the n equal to 2, right? What will happen if you assign the fast and slow? Fast and slow will go from here. The fast will reach here, the slow will reach here, and then the system will break, right? The fast is okay. So this is our slow. Now since this is our slow, what we want is the length of n is equal to 2, right? uh, so this is the last, this is the okay, nth node from the end of the list and returns its head. So n is equal to 2 is second, right? Yeah, so this is this value, but we know the mid, we know the n, right? So if you think which node, uh okay, so we have here one, so one part is here and one part is here. Now what we need the second from the second node from the end, which will be equivalent to what we can say is the second node from the end, which will be basically, if okay, we have the length of the, let's say, linked list. So the simple method is to calculate the length, subtract check. So the size of length is 4. We can just do 4 minus whatever it is, 2. This will give us 4 is the length, 2 is length from backward. That will give us the 2, which is the obviously the second index, the index that we want to remove. Then we can just go there, or we can just do the 2 hops. So this is the 2 hops, and then you can just directly connect it to next, right? Yeah, this is what it should be. So let's we can start implementing it. So let's find the length. So let's take the L equal to 0 and traverse. Uh, so let's take the start to be equal to head, and then we'll just traverse it, meaning that while start dot next. Let's take that to be 1. So while start dot next, we'll just start equal to start dot next. Start equal to start dot next, just increase the length by 1. This is our length. Now what will the point from start? So from start its value will be L minus N. I will also minus 1 as well. So for example, if this is let's consider the N equal to 1, so difference will be 3, right? So we'll hop the two times and then we'll reach there. Yeah. So this is our the wall, and then let's say while wall, right? We can do again we can store temp to be head. We can say temp equal to head, and while it's wall, we can say temp would be temp dot next. We'll go to the next part, and then from here everything will start. So what we'll be doing here, so we'll just assign temp dot next would be equal to temp dot next. So here is then we'll just bypassing everything, and then we'll just there are several caveat, but let's bear it with this for now. So what do we type next? What runtime object, is that right? Temp is equal to temp dot next. This is incorrect. correct, right? What's wrong with this? Head is 1, 2, n is equal to 2. We want to remove 1. What is the start here? Man. Very filthy code. So let's see here. Our method is also on. So let's check what they are doing is they have created the dummy. They have a left dummy and we know why they have the right one. So I think okay, this is the dummy size 0 and they have it in the head, I believe. Left dummy is dummy, right dummy is head. And while n is greater than 0, they're going to the right and they are reducing the n, and then while right, left equal to left dot next. Okay, and left equal to left dot next, right equal to right dot next, left dot next equal to left dot next. So this is what they have skipped. So they are saying that after left. So okay, they are was it and then while right. Yeah, that also does make sense. So what they are doing is uh, this is the array and they're saying n equal to 2, which we have to remove 4. So they are saying okay, what is the size? The size is 5. So okay, we'll go to 2, that will be here, and then we'll start from here because the remaining will be uh like the length that is from here, right? So here we'll traverse this part, which is the left length will be remaining, right? So which is equal to coming from here. So by 3 we'll come here and then we'll just move to the next element. Yeah, so let's say code implementation. So what's the hard problem? I think this is the last one from the linked list. And like yeah, I so much wanted to complete all these 75. Okay, merge key sorted linked list. So you're giving an array of k linked list where each list is sorted in ascending order. Linked list and return the sorted linked list. That is a result of merging all the individual links. Why it is hard? We have to just keep the pointer right and then we just have to update. This is the case. What can be the length of key? Let me just check. Just written one sorted linked list, right? We will be having k pointers and then I think it's better to create just one linked list. This increase the pointer. Check out of those pointers that are not null. Only on those pointers, just check. So let's start. So we'll create a list of pointers. Here, what we'll do is we'll create a list of pointers we have created. From all this list of pointers is this. Then we will iterate for L in lists. Just go in them, and what we'll do here is list pointers dot append uh, dot append lists, the zeroth one, right? So this zero is, yeah, just take this. Now we'll create a list that we call as dummy as well. Simply list node, and let's say size is 0, right? And then now uh, I will traverse all the possible lists. Let's say n is the size of or length of lists. So here now I have the n, and we have all the pointers, and then we'll just iterate. Uh, yeah, you have to just iterate until everyone is none, right? Yeah. So yeah, these are the list. I'll just take in a list 0 or L0. This is the list node, right? This is a list node. You don't need that as a. So here I can just say for ln list. So I'll iterate to, then what we'll do, vol the value will be the minimum of, I'll just put take the minimum, and then I'll just append, because all of these is are sorted, right? What I wanted to do, I wanted to take the minimum of all the lists and then just and that node here. So what is equal to, I will just put this will be the temp. Temp is equal to right. It will go to all the list and it will just take the temp for all of these lists, right? And then what it will do, it will just do res dot next equal to L. I in range n, temp ball is less than list I dot for temp equal to list let's I, and then let's 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 lists let's I equal to let's I dot next. Let's I right. So so there's this, the I will be the last one, right? So we cannot append, we'll just append here. So once they have taken, we will increase. Correct. Until when we will do it. Temp dot next is inside it will come. So the result dot next will be equal to temp. Okay. And then what we'll do is temp dot next is enough. But the question is until when we'll be doing this. So if temp I it's going till I in the range of n, so it went to all, it took the node element and the node is increased to next. Now temp is itna, so we have to do it until all the list is none, right? So yeah, so here what we can say, there will be one more loop that will dot next equal to temp and rest will be equal to temp, right? Per sorted list node equal to, let's say, res will be returning sorted list node dot next. Yeah, this is what it should look like. There's one more while thing to be added. The while thing is and the temp value. Okay, So while so the range is very big. The integer list IC. What? What? What is J? This shortest man. What was shortest? What is temp equal to? Okay, if temp dot fall is less than, so temp will create. Okay, so while for I in range L, we'll go through all the list. We will find the minimal list and then we'll edit or return. That's correct. Okay. While while L in lists, if L is not while flag so what I'm thinking is I will just go through all the lists and then I'll see okay if any of the list is non-zero I'll go again. If L is not none, I think this should be so. Here we're going. Okay, we find not none. Some of them we find them not none. So we're saying okay, go and find out. And then if any of them in we are saying okay, while in list completed, it will go again to a riddle. Now everything is none. Okay, this does make sense. Now we have to define temp. If everything is not none, then can say temp is list node and let give it very big value. Now it got some list I is list I dot none. I is in range, so it just scans everything, but it is scans in a way. It does not scans everyone, right? So show. So okay, once let it scan everything, and once it has scanned everything, after that only we can do the rest. So here we have to initialize I equal to 0. Then I will go 10. The time will get updated. Okay, now we got the I, like the last I. Looks pretty messy, but L was not declared. Yeah, L is not declared. Macha. Yeah, guys, I think this is it. I'll see you tomorrow and then we'll solve it after. Bye bye.